Hi everyone, welcome to Vedantu English. I'm Diksha Ma'am, your chemistry master teacher. So everybody, let me know in the comment section if I'm clearly visible and audible or not. Today we are going to do questions of SRMJEE, right? Very important exam. And I would say in comparison to JEE, easy questions are asked here, right? So you will be easily able to qualify the exam if your basics are clear, right? It's not like very high level questions are asked, very similar kind of questions to JEE are asked, or even the previous year of questions of JEE, they asked frequently, right? The only difference, the syllabus also I have sent you on the Telegram channel itself. Then we have seen that the difference in the G syllabus and SLMG surface chemistry. So surface chemistry is an additional topic that is not there in JEE Mains, but that is there in SRMJEE 2025. So you have to go through that colligative properties like leophobic, loophobic, all these things, colloidal solution, Tyndall effect, Brownian movement, very simple topics they are. Then you have to go through them once, right? Okay. So now let us start this session, students, without wasting any time, right? Okay, everybody, are you ready for the class? Yes, students. Is the voice low? Voice problem. Okay. Wait a minute. Let me see. Okay. Now tell me, is the voice clear now? I think I connected the wrong mic by mistake. Okay. So is the voice clear to everybody now? Ma'am, sound problem, that is okay, right? Okay, I think I by mistake connected the wrong mic here. That's why that problem arose. Okay. Yes. If that is clear, then spam this chat box with green hearts and just click on the like button here if the voice is audible to you, if I am visible to you, right? Okay. Yes, ma'am. Okay, so that means the voice is correct now. So let us start these questions, right? Okay, so I have picked up some questions from the official site of SRMJEE, right? The model papers of SRMJEE and some questions from JEE Mains. Okay, so it's a mixture of all of the questions that are important for your exam, right? Based on what is the criteria, what are the easy questions that they can ask directly in SRMJEE from JEE Mains, what are the questions that they will ask, like from the model papers, how easy questions they ask you, right? Everything I have already covered in this particular, like this video or this lecture is going to give you a perspective of what is going to happen in your exam, right? Okay, so first question, as you can see on your screen, is the statement that is not correct. Okay, so first is angular momentum number signifies shape of the orbital. Angular quantum number. Angular quantum number means they are talking about azimuthal quantum number. In angular momentum, we use L, right? So angular quantum number is nothing but it is azimuthal quantum number, which signifies the shape of the orbital. That is correct. Next is energies of stationary states in the hydrogen-like atom is inversely proportional to the square of principal quantum number, right? So energies of energies of stationary states in hydrogen-like atom is inversely proportional to the square of principal quantum number. Yes, that is also correct. The number of nodes for 3s is 3. Okay, so what is the number of nodes? Node means n minus 1. So n is 3, 3 minus 1 is going to be 2. So that corresponds to be the incorrect statement here. Rest is the radius of first orbit of helium positive is half of that of first orbit of hydrogen atom. The radius of first orbit of helium positive. Radius is what? Radius is equals to directly proportional to n square by z. So if I say radius of first orbit of helium means for helium positive we know that is directly proportional to n means orbit. Orbit number is 1, so it is 2 square divided by 2, that will correspond to be 2, right? I am not writing a naught here, so you can say just exactly the value will be 2 a naught. Okay, for radius of hydrogen It is that of first orbit, right? First orbit of is half of, okay. So first orbit of hydrogen means this is A naught, this is N square, this is Z. N for hydrogen they are saying is 1, Z is also 1 for hydrogen, so that is A naught. So we can say that the radius of first orbit of helium is half. Definitely that is coming out to be half here. Radius of the first orbit of helium positive is half that of first orbit of hydrogen. Wait a minute. N square by Z, Z is 2. So that will come out to be 2 only, na? So, so answer is going to be 3 is the incorrect, right? So I think it should be written the radius of first orbit of helium positive is half. I would say it should be double, isn't it? Right? Okay. So option C is correct. This slight change in the statement is needed here, right? Okay. Next question is, for a dilute solution, Raoult's law states that, Raoult's law is what Raoult's law means? The vapor pressure, this is Raoult's law, vapor pressure, or you can say partial pressure is equals to vapor pressure multiplied by the mole fraction. The lowering in vapor pressure is equals to mole fraction. Okay, they are saying for a dilute, Raoult's law states that. What do you mean by Raoult's law? Relative lowering in vapor pressure is equals to the mole fraction of solute. The relative, I think the question is not correct here. I have not seen this question. The question should be, which of the following statement is incorrect? Okay, the question should be, which of following is incorrect? Is correct. Okay, it should be which of the following is correct here. So as you can see, the lowering in vapor pressure is equal to the mole fraction. That is not correct. Mole fraction of the solute. Okay, lowering in vapor pressure. Lowering means delta P. Delta P is directly proportional to mole fraction of solute. That is not correct. The relative lowering in vapor pressure is it. Relative lowering in vapor pressure is equals to mole fraction of the solute. That is the correct statement. Okay. So if they ask you which of the following is the correct statement, the answer will be B is the correct answer. As you can see, relative lowering in vapor pressure is equals to mole fraction of solute, and that also we are talking about solute, not solvent. Okay. Here they have mentioned solute in the solution. Here they have mentioned mole fraction of the solvent. That is not correct, right? Okay. Next is, you have a compound that is K2HgI4. This is a very, very important compound. They can directly ask you what is the dissociation, what is the value of N here, in how many ions it will dissociate, right? Is 40%. That means alpha is given to be 0.4. Okay, alpha is given to you, that is 0.4. The value of its bond Hoff factor, that is I, they are asking you, right? So directly what you have to do, firstly you should know how many ions it is getting dissociated into. So it's very, very important that when you have K2HgI4, this will be dissociated into 2K, right, plus HgI4, 2 negative. That means totally number of ions is going to be 3 in which it is going to dissociate, right? Next is, what is the formula of dissociation and alpha and bond Hoff factor? The formula is I is equals to 1 plus alpha n minus 1. So here n value is 3, alpha value is given to be 0.4. From there, directly putting the values, you can easily get the value of I, that is come out to be 1.8. So answer is going to be B is the correct answer, right? Next is, for hydrogen oxygen fuel cell at 1 atmospheric. So when you have hydrogen oxygen fuel cell at 1 atmospheric and this much temperature, this is the equation that is given to you. Delta G is already given to you. E naught for cell is approximately given by. So whenever they ask you either Nernst equation or a question of delta G and E naught is definitely going to be there in your exam. So here it is going to be delta G is equals to minus NF E naught of cell. Okay. So here easily how you can put the value? N factor. First is number of electrons. This you have to see. E naught is given to, E naught is what they are asking you. Delta G is given to you. Faraday's 96500. So here you have to see that how many electrons are getting exchanged here, right? So if you see this here, I think that was not written, H2 plus half O2 H2O. So I'll just write it here only, right? I'll just write it here only. How you're going to see the number of electrons, right? So this is H2 plus half of O2 give rise to H2. So if you see this here, H is basically in zero oxidation state, right? Here we know that oxygen is in minus oxidation state, hydrogen is in plus one oxidation state. Here oxygen is in zero oxidation state. So what we can see, 0 to -2, and for 0 to -2 is for oxygen, right? So this is 0 to -2. That means 2 electrons are getting gained here. And in this case, 0 to +1. You will say, ma'am, 0 to +1. 0 to +1 is for 1 hydrogen. For 2 hydrogen, because here you have 2 hydrogen, here you have 2 hydrogen. Oxygen, you have only 1. Here also 1 oxygen, here also 1 oxygen. That is why for 2 hydrogen atom, it is going to be 0 to +2. So N factor is going to be number of electron gained or lost is going to be 2. So we'll put the value of N factor as 2 here. Faraday is 96500. E naught value you have to calculate. And one more thing you should remember is, if this is given in kilojoules, okay? So if this is given in kilojoules, right, that is given in kilojoules, you have to find this value in volt. Then you have to put the value of delta G in joules, not in kilojoules. Okay, so you have to convert this into kilojoules by multiplying by 10 raised to power 3, and then only you will get your answer in volt, right? So units also plays a very important role. In hurry, don't do this ki, okay ma'am, we have just put the value directly in kilojoules. You have to convert this into kilojoules to joules, right? Okay, some silly mistakes also I am telling you in between. Next is the molar boiling point elevation constant for water is 0.510 Kelvin per mole kg, right? Molar boiling point elevation constant, that means Kb is given to you, right? The boiling point of solution made by dissolving this much gram of urea, that is weight is given to you, W2 is given to you, W1, that is weight of solvent, is also given to you. Now, we know that molar mass of solute, that is molar mass of urea. What is urea? It is NH2CONH2. When you calculate the molar mass, it will come out to be 60, right? Now, you just have to put the values here. They are asking you the boiling point of the solution made by dissolving this. So, if you see this, delta TB is equals to, because there is elevation in boiling point, right? So that means this will be TB minus TB naught is equals to, this is urea. Urea is a non-electrolyte. Urea is a non-electrolyte. So that means, wait a minute. So that means Van Hoff factor will be equals to 1 only. So we don't need to write Van Hoff factor. This will be M into KB. What is MM? M is molality. Molality is weight, or you can say number of moles of solute divided by weight of solvent. If it is in gram, this will be multiplied by 1000 here, then multiplied by KB here, that is given to be 0.510. Okay, then you have to put the values here. What is this TB naught? TB naught is going to be 100, because generally the boiling point of water is, if it is pure solvent, that is only water, then boiling point of water is 100, right? So you have, they are asking you to calculate the value of TB, the boiling point of solution, that is TB they are asking you. So you'll have to put these values. W2 is given to be 6 gram, beta 2 always represents solute, 1 represents solvent, okay? So 6 divided by molar mass is given to be 60, right? Multiplied by 1000, divided by W1 is given to be 200, multiplied by 0.510, right? And here you will add, here in all of this, you will add 100 here, and then you will get your answer, okay? This is the answer that you will get here, right? Okay, understood? Right. So after this, answer that you will get is 100.255. Calculation, you will do that yourself only, right? Next is, for an ideal binary liquid solution, they are asking you for an ideal binary liquid solution, Delta S and delta G they are asking you. Now listen to me very, very carefully that for an ideal solution, delta H and delta is V is equals to 0. V mix and H mix is equals to 0. But delta S is always increasing. Delta G should always be negative. Doesn't matter whether it's any ideal solution, non-ideal solution, it doesn't matter. So always it is going to be, you can see entropy should always increase, gives free energy should always decrease. It should be negative here. That is the final statement. So answer is going to be D is the correct answer. Is that clear? Is that clear, students? Yes, everybody? Right. Now here, what is the conjugate base of OH negative? Now basically, ma'am, what is the conjugate base? So if you see an acid, right, after losing H positive forms conjugate base. Okay, conjugate base, or a base after, or you can also say a base after accepting H positive forms conjugate acid, right? Now they are asking you the conjugate base. That means you have to take out one H positive from here. So when you take out one H positive, it will become O2 negative. So answer will be O2 negative. That is A is the correct answer. Now there are some compounds which are both behaving as conjugate, behaving as Bronsted acid and Bronsted base. How? For example, you have HCO3 negative. If it accepts H positive, it will become H2CO3. If it loses H positive, it will become CO3 2 negative. So this compound has both conjugate base, conjugate acid as well. This is conjugate acid and this is conjugate base. It has both conjugate acid and both conjugate base in its function, right? So is that clear? Is that I can see no energy. Ma'am, this exam is easy. So no energy, ma'am. We will also lose our seat in SRMJEE, ma'am. No matter the college is good, ma'am, we will lose the seat. Why? Because, ma'am, we will only do hard work when the exam is tough. But it is so tough that, ma'am, we were not able to do that. But now, ma'am, we know that this is like we can do that even now. But still, we will not be serious, right? Why? Because, ma'am, we are. If we get serious and if I got admission, then what is the use, ma'am? I'll get good placement, good salary, everything will be happy in my life. I don't want that, ma'am. I want to chit chat in the comment section so that these people who are there in the chat box, they don't even know me after like 10 days or 5 days. You don't know their identity, who these people are, right? What they are doing. Maybe they are someone who is already BTech and just trying to waste everyone's time here, or maybe some psycho is over here, right? So there are so many things. You also make strangers your friends on these chat box, and you never know what is the intention of that person, right? So don't waste your time. I am so happy only. I am not sharing all my personal information on the chat box. What's your Insta ID, this and that you are sharing with these strangers. You don't even know, this may be some 50 or 60-year-old, some psycho person, right? So you never know who is that person out there, right? That may be a 10-year-old kid who has no idea what that kid is doing, right? So be very, very serious about this, right? Integrated rate law equation for first order gas phase reaction is given by which of the following? Okay, so integrated rate law equation you have to tell for which thing is given by which of the following. So definitely we are going to see this. P is the pressure, this is the total temperature. Okay, so a simple equation is given to us. A give rise to B plus C, right? Now here Pi is the initial pressure, this is 0, this is 0. So now we know that X amount will be taken out here. So this is Pi minus X amount is formed because stoichiometry is 1, X amount will be formed here, right? Now here, what is the total pressure? That is the addition of all of this. When I added all of this, these two will cancel and I'll have Pt is equals to Pi plus X, right? but I have to find the value of Pi minus x. Pi minus x is going to be, from here, Pi will be equals to Pt minus x, right? Or you can just see the value of x here. X will be equals to Pt minus Pi. Put the value of x here in Pi minus x, because that is the final pressure. And in rate law equation, integrated rate law, we always write initial by final. Okay, so this is the final pressure. So Pi minus x, that is Pi minus Pt minus Pi. So that is going to be Pi minus Pt, this is T, plus of Pi, that is going to be 2 of Pi minus Pt. Minus Pt is what they have written here directly. 2 Pi minus Pt is the value of final pressure. Final pressure. We know the value of rate constant is K is equals to 2.33 by T log of initial by final. Initial is given to be Pi, final is given to be Pi minus x, that is nothing but it is 2 Pi minus Pt. So answer is going to be, this is your final answer, right? So answer is A is the correct answer. That is clear? Okay. Next is for the first order reaction. Now they are asking you for the first order reaction. The time required for completion of 90% reaction is x times. So time required for completion of 90% reaction is x time that of half-life of the reaction, the value of x they are asking you. Okay. So how many times it is, right? So here what you have to do, 90% means we have to find the time is equals to 2.303 by K log of initial is what? Initial is, let's say, 100. So final will be 100 minus 90, that is going to be 10. So log 10 is nothing but it is 1. So it is 2.303 divided by K. This is T. Now we also know that the value of T half is equals to 0.693 divided by K. So if I put the value of K is equals to 0.693 divided by T half, if I put the value of K here, that is 0.693 divided by T half. What is this value? This is what they are asking you. For a first order reaction, the time required for completion of this is x time that of half-life. So what is this answer? That is going to be your answer for x, right? So when you solve this, this is going to be 3.32. Okay, when you solve this, this is going to be 3.32. So I'll just put directly the value 3.32 is that of T half, and this is what they have regarded as x here. So x is going to be 3.32, that is C is going to be the correct answer here, right? Next question is for Cr2O7 2 negative, this is an equation that is given to you, right? They have given us the E naught value here. They have add this is equals to, okay, they are saying also concentration is also given to you for Cr2O7 2 negative. This concentration is given. For chromium 3 positive also concentration is given, right? Concentration of H positive is not given to us, but they are asking you E value also they have given. They are asking you the value of pH. That means if I am able to calculate the value of H positive, right, that is the concentration. So pH will be easy, that is minus log of H positive here, right? So calculation might be a task here. Otherwise, the question is, I would say, yes, that is a good question here. So if you see this here, that is going to be this reaction. We know that N factor is 6 electrons are getting lost and gained. It is given in the reaction itself. So this is the Nernst equation. Nernst equation is E is equals to E naught. E naught is given, E is given, R and T we already know. Achha, what will you put the value of R here? R you will put it as, wait a minute, you don't even need to put the value of R because this value we already know, that is 0.059, or you can just directly write 0.06, right? Okay, this is given to be 6, this is already given. Now log is product by reactants. On the product side you have Cr3 positive, you have water, you have H positive, you have Cr2O7 2 negative. See, for water, definitely it is 1 only, so you can just directly put 1 here because it is in liquid state. We don't need to worry about that. Of pure liquid, the concentration of pure liquid is 1 only, so we don't need to worry about that. Just put it 1 here. Now, for Cr3 positive, it is given to be 15 into 10 raised power minus 3. For Cr2O7, that is given to be 4.5 into 10 raised power minus 3. That is given here and here. Right, millimoles. Milli means 10 raised to power minus 3. Okay, milli means 10 raised to power minus 3. Okay, these two things are given to us. Now, H positive concentration you have to calculate. Right, H positive concentration, solving all of this, you will calculate the value of H positive. From that, you will take the log of H positive, then take minus and then log of H positive. That will be your answer. That will come out to be 1.7955. Okay, so that is how you're going to solve the answer from Nernst equation, right? Next question is, in each period, the strongest oxidizing behavior, if you talk about oxidizing behavior, in a period, in each period, they are giving alkali metal, noble gases, halogens, chalcogens. Oxidizing means someone who is going to oxidize something else. They are going to make them lose their electron. They are going to gain the electron, the one who has more electronegativity. F2 is the strongest oxidizing agent here. So halogens is the one which has strongest oxidizing agent among the different groups here. So answer is C is the correct answer. Next question is, which molecule has the largest dipole moment? Largest dipole moment, if you talk about dipole moment. So they have given HCl, HI, HBr, HF. Okay. HCl, we know that fluorine, bromine, iodine, right? So this has maximum electronegativity. Maximum electronegativity means the difference in hydrogen hydride, or you can say proton, and the halide ion, that is the F negative or I negative or Cl negative, that is going to be X negative, is going to be maximum in this HF, right? Because hydrogen is having the same electronegativity, but fluorine, chlorine, bromine, iodine have different. Fluorine has maximum, that is the reason fluorine will have the maximum dipole moment because of the electronegativity difference here. Is that clear? Okay. Next is the correct order of melting point of hydrides of group 15, of group 16 elements are. Now, they are asking you melting points here. Melting points. So now we know that melting points order is going to increase down the group, right? But here, what exactly happens here? The exception is H2O here. H2O, because of the hydrogen bonding, we didn't expect that it will have the maximum melting point, but it does have the maximum melting point. So answer is going to be, this is decreasing down, increasing down the group. Yes, that is definitely right. It is going to increase down the group because the size is increasing, right? Okay. But this, because of the hydrogen bonding, has the maximum melting point here. So answer is going to be A. Next question on your screen is, given below are two statements. One is labeled as assertion, reasoning. Okay. Fluorine forms one oxo acid. Is it correct or not? That is definitely correct. These are factual questions. Okay. Fluorine definitely forms only one oxo acid. But what is the reason behind that? Fluorine has smallest size amongst all halogens and is highly electronegative. That is also true. Now, is it a correct answer for this question? If I say why fluorine forms one oxo acid, because it is smallest and it is highly electronegative, that is why it is not able to form more oxo acids. So answer is going to be both A and R are correct, and our reasoning is the correct explanation of the assertion, right? Next question is, in 3D, let us see how many of you are able to answer this. How many of you are able to answer this? Let us see. In 3D series, the metal having highest M2 positive M standard electrode potential. If you see this here, in 3D series, the metal having highest M2 positive to M. If you see M2 positive 2m. This is given in your NCERT table. Copper, which is having plus 0.34, is the only one which has positive electrode potential of Cu to positive to Cu. That is why highest is going to be copper. So answer is going to be C is the correct answer. Next, very, very important question. The f orbitals are half and completely filled respectively in lanthanide ions, right? They are asking you f orbitals which are half filled and completely filled. For that, beta, you have to see this. Just students, first thing what you need to do is see this table here. This electronic configuration is highly important. I'll tell you, you don't have to cram the full chart here. Just remember few. Okay. I'll tell you, first is 4f7 and 4f0. That is cerium. Here you can just write cerium 4 positive, and this is terbium 4 positive. That is half filled. This is terbium 4 positive. Okay. So these two are important for you. Next is in 3 positive state, you have lanthanum, you have gadolinium, right? Then you have lutetium. Okay. Lanthanum, gadolinium, lutetium, and lanthanum. This is in +3 state. This is in +3 state. This is in +3 state, which is having half filled or fully filled. Then in 2 positive state, you have europium, that is stable in 2 positive state. And then you have ytterbium, that is stable in +2 state, right? This you can write, this is stable in +4, and this also is stable in, cerium is also stable in +4. These are some of the very, very important electronic configurations, right? It is a must to do. Right now, let us see what is the question that they are asking. Half and completely filled respectively in lanthanoid ions, half filled. So half filled, you have europium, samarium, terbium. Okay, dy, this is already eliminated. It is never half filled or fully filled. This is also never half filled or fully filled. Either this or this. Europium 2 positive, if you see, europium 2 positive is a 4f7, right? That is half filled. Terbium 4 positive is half filled. So both are half filled, right? Europium and terbium both are half filled. Completely filled, now here we have Tm, here we have Ib, so this is also eliminated. So answer is going to be terbium and ytterbium. So answer is going to be C is the correct answer. Okay? Even if you don't learn these things, even then you will be able to answer this. If you at least know, let's imagine there is some person who don't know which is half filled, which is fully filled. Now I told you, just remember lanthanum, cerium 4 positive, gadolinium 4 positive, cerium 4 positive, terbium 4 positive, cerium and terbium 4 positive, gadolinium and lutetium, lanthanum 3 positive. Then you have 2 positive europium and you have ytterbium, right? All these are your stable electronic configuration. So this is not stable, this is not stable, this is not stable, this is not stable. So only option in which both are stable, we are left with C. So you don't even need to know which is fully filled or half filled if you know that which one are the stable electronic configuration in which state. Okay? Understood? Now, next question is, in CH3, these are some of the questions from your model papers only, right? In CH3, thrice in the state of hybridization. This is N, lone pair, this is CH3, this is CH3. Okay, state of hybridization of N atom and spatial rearrangement of methyl group around R respectively. So if you say spatial rearrangement, right? So firstly, what is the hybridization? 3 sigma 1 lone pair, that is sp3. So this is not correct. Now whether it's trigonal planar, no, definitely not. It is not trigonal planar. The geometry here is going to be geometry, beta. What is the geometry? The geometry is going to be tetrahedral, and the shape is going to be trigonal pyramidal, and because of the repulsions also the angle will slightly change here, right? So here they have given us only geometry, so answer is going to be A is the correct answer, right? Okay, the spatial rearrangement of methyl groups around it are respectively, right? Okay, Wait a minute, they are asking you the rearrangement of only the methyl groups. They are not asking you the lone pair here. They have asked you rearrangement of only methyl groups around it. So if you talk about only methyl groups, that means they are asking about shape, and in shape you have trigonal pyramidal, that means pyramidal shape, that is B is the correct answer. Okay. Next is, which of the following compound, which complex cannot ionize in solution? These are the kind of questions that we can expect in this exam, right? So here definitely the one that has the ions outside the coordination bracket, then definitely they can ionize. This can ionize, this can also ionize, this can also ionize. You have NH4 outside, you have Na2 outside, you have Br outside, but here everything is inside the coordination bracket, so it cannot ionize. So answer is D is the correct answer, right? Okay. Next is, KMnO4 act as oxidizing agent in alkaline medium. Very, very important question. Very important question. KMnO4 is a very strong oxidizing agent. In alkaline medium, it converts I2 to IO3 negative, right? That is iodate ion, that is C. In acidic medium, it is converted to I negative. I negative na? Huh. I negative is converted to IO3, and here I negative is converted to I2 in the acidic medium, right? So answer here is going to be C is the correct answer. Next is very, very important, that is phosphoric acid. Which phosphoric acid is tetrabasic in nature? Tetrabasic means which can donate you 4 H positive, that is going to be tetrabasic. For that, metaphosphoric, orthophosphoric, pyrophosphoric, hypophosphorus acid, which of the following? So all of these are oxo acids of phosphorus. You have to learn the oxo acids of phosphorus and sulfur. They are very important when we talk about SRMJEE, right? Because in JEE means it's not very important for you, but if you talk about this SRMJEE, it is important for you, right? So few topics that are not so important in case of JEE, but they are important in case of SRMJEE, right? So here it is. We have pyrophosphoric acid, phosphoric acid, that is basically P2O7H4, H4P2O7, right? So here it is 1, 2, 3, 4. 4 OH, that means it has 4 H positive that can be donated. That is why it is tetrabasic in nature. Hence, answer is C is the correct answer. That is pyrophosphoric acid is the correct answer here. Next is the pair of compounds identical. Pair of compound having identical shapes for their molecules, right? Identical shapes, right? If you can see, the formula is given to be identical here, right? But the shapes are different, right? So students, directly I'll write the shapes here. We know that how to calculate this. This is from hybridization. This is coming out to be CH4. For sulfur, it is like this. You have seesaw shape like this. 1, 2, 3, 4, and 1 loop pair. How to calculate this, ma'am? Sulfur is belonging to group number 16. 6th outermost electron, that means. Now, it is already, if I talk about SF4, it is already having 4 bonds. That means I'll subtract 4 from here. 2 electron means 1 lone pair. Once you know 1 lone pair plus 4 bond pair means 5. That means 5 means it is D, you can say sp3d, that is trigonal bipyramidal. This is trigonal bipyramidal. But when we have to put 1 lone pair, we will always put it on the equatorial position. Rest of it will be these two are axial, and this one are your equatorial positions, right? So that is why the shape is going to be seesaw here. So they don't have identical shapes. So answer is no. What about BCl2 and ClF3? Definitely not. So what about these two? So if we talk about BCl2 is, I think it should be BCl3. formula at least should be correct, na? So it should be BCl3. So BCl3 is nothing but it is a trigonal planar geometry, because boron has it is electron deficient definitely, and it is having 6 outermost electrons. So all are occupied with having a bond with the chlorine, right? Next is ClF5, ClF3. So ClF3 again same way. Chlorine is having belonging to group number 17. That means it has 7 outermost electron. 3 bonds are already occupied here. 7 minus 3, we have 4 electrons. 4 electron means 2 lone pair. So 2 lone pair plus you have 3 bond pairs, so it is 5. So it is again trigonal bipyramidal only. That means we will draw it like this only, Cl 1, 2, 3, 4, 5. But here you have 2 lone pairs, right? So here one lone pair will be, both the lone pair will be on the equatorial position like this. So here the geometry will be T. So definitely BCl3 and CF3 is obviously not the same geometry here, right? Next is XCF2. XCF2, I have high hopes on ZnCl2 and XCF2, because SO2 and CO2 is also not the same. SO2 is basically like this. Okay. So CO2 is like this. CO2 is like this. The only difference is sulfur is belonging to group number 16. So it has 6 outermost electron. That is why after forming double bond, it is still left with one lone pair. But carbon belonging to group number 14 only has 4 outermost electron. So that is why already all the bonds, all the electrons are occupied here. That is why the same geometry is going to be of neither this. The answer will be ZnCl2 and XCF2 definitely, right? Okay, the answer will be, wait a minute, I think by mistake I have some other thing here, right? So answer is going to be XCF2 and ZnCl2 for sure, right? Okay, and ma'am, what is the shape here of XCF2? So you can just directly write the shape here. See, XCF2 is, xenon is belonging to group number 18, minus 2 electrons, so it will be 6 electron, that means 3 lone pair. 3 lone pair plus 2 bond pair, again it is sp3d2, so it is Xc 1, 2, 3, 4, 5. Here you have 3 lone pairs, so answer will be, lone pair will be on the equatorial position here, and it is going to show you a linear shape, and ZnCl2 also has a linear shape. Okay, so answer is going to be C is the correct answer. Okay, understood everybody? Next is gold sol. Now some questions from your surface chemistry. Let us see those questions, right? So here it is, gold sol. This for your reference, this is not there in JEE Mains 2025, right? Okay, so gold sol is not a macroscopic macromolecular colloid, a leophobic colloid, a multi-molecular colloid, a negatively charged colloid. So gold sol, right? So gold sol is basically in the colloidal solution. There is a table in surface chemistry where you get to know different solutions, right? So in that you have gold soil where they're asking you leophobic. It is definitely leophobic. Multi-molecular, yes. Negatively charged colloid, yes. So answer will be, it is not a macromolecular colloid. For example, polymer, starch, protein, enzymes, right? These are not macromolecular colloid. So answer is A is the correct answer, right? Next is the IUPAC naming of complex ion found when gold dissolved in aqua regia. When gold is dissolved in aqua regia, right? We know that there are some things like platinum, gold, which can only be dissolved in aqua regia. So here, which thing will be formed is HAUCl4, right? So that is tetrachlorido aurate is the correct answer. If you see this, this is plus, this is plus, this is minus 1. So x minus 4 is equals to minus 1, x is going to be plus 3. That is why here you have plus 3, right? And why, ma'am, here we have aurate, not gold? Because the metal ion is in the anion part. Okay, so that is why this will behave, this will give its Latin name, that is aurate. And always you have 8 in the end when the metal is in the anionic part, right? Okay. Next is the species that is not hydrolyzed in water, right? The species that is not hydrolyzed in water. P4A10, BaO2, Mg3N2, and CaC2. So if you see P, Mg, and Ca, they will hydrolyze how? So firstly, P4O10, all these are reactions in your S block. Okay, you will see in block chemistry you have all these reactions. Okay, so here it is H3PO4, it is forming Mg3N2, it is forming magnesium hydroxide. CaC2 is also forming calcium hydroxide. If you see, this is also a very useful thing in organic chemistry as well, how this reacts to form calcium hydroxide, how this reacts to form magnesium hydroxide. Right, so answer is BaO2 will not react with water at all. Right, okay. Next is correct arrangement for the ions in increasing order of their radii here. Okay, so as you can see, this is a question from isoelectronic species, which is again a very important topic. See, these kind of topics are memory based, not memory based, I would say cramming based questions, right? If you feel like, ma'am, I won't be able to cram too many reactions, right? If you're someone who is like, ma'am, I am not able to cram, these questions will be there in the exam. I'm not saying not will be there. This, at least one question will be there based on some kind of fact, logic, reaction, something like that, right? If you don't want to do these kind of questions, right, you can skip these reactions, but these are the questions that will fetch you marks. That is isoelectronic. So here definitely if they ask you the size, that is directly proportional to more is the charge on anion, inversely proportional to charge on cation, inversely proportional to charge on cation. So here all of these are cations only. They are showing increasing order of the correct arrangement in increasing order of their radii. This is definitely not the correct arrangement because Cl negative, wait a minute, Cl negative is not even isoelectronic. Cl negative is not even isoelectronic here, right? It is having 18 electron, it is having 10 electron, it is having how many? 10 electrons. Okay, it is having 10 electrons. No, it is not having 10 electrons. Potassium, and this is S2 negative. These are not isoelectronic. I can't say these are isoelectronic. Okay. I think we have to use 2-3 concepts here. First is of isoelectronic, other is general periodic classification, that along the period size will decrease, down the group size will increase. So if you place these things here, so this is sodium is in the first group, calcium is in the second group, okay, somewhere here. Beta mange car, so this is Lina ki, okay, right, so here it is chlorine is somewhere here, right? Chlorine is somewhere here. So definitely if you talk about the size of Ca2 positive, that cannot be maximum here, right? Okay, because Cl is going to be maximum, so that cannot be the correct answer, right? Ca2 positive, then you have K positive, that means S2 negative is the maximum here. Again, here if we write the correct orders of the sizes here, again sulfur is going to be, sulfur belongs to group number 16, this belongs to group number 2, this belongs to group number 1, potassium is somewhere here, calcium is somewhere here, and sulfur is somewhere here, right? Okay, sulfur 2 negative, this is increasing, right? So how many electrons you have here? Again, this can be the correct answer. If you talk about NaAl and Be, then chlorine, fluorine, and sulfur, again fluorine is the smallest, right? Here you are decreasing, again that cannot be. So my idea is either B or C, है ना? So if you see this, sulfur, atomic number, number of protons, number of electrons, everything is given to you here, right? So according to that, the answer will be Ca2 positive, K positive, and S2 positive are isoelectronic species. Wait a minute, how these are isoelectronic? 20 minus 2, 19, 16, 17, 18.
So this is 18, this is also 18, this is also 18. Yes. Okay. Yes. Because here though you are not able to predict anything. Here though you are not able to predict, and this cannot be the correct answer. But here you can, right? Because all of these has 18 electrons, right? Okay. So here though you were not able to predict anything, but here you can predict here, right? So now from here we can see the negative charge is having the maximum, right? That will be have the maximum size. Then positive charge is inversely proportional. So more is the charge, less will be the size. So that is why calcium 2 positive is going to have the minimum size here. So answer will be B is the correct answer. Again in sodium, aluminium, beryllium, again these are not isoelectronic. Chlorine, fluorine and sulfur. Fluorine will not be isoelectronic with the chlorine. So again these things are not possible. This we can only understand with the help of periodic table. If this we can easily say that okay these are isoelectronic, directly with this relation you can find out for isoelectronic species. But here the interesting part is not all of them are isoelectronic. Only here you will see isoelectronic species, right? Okay. Next we have a correct statement. Now they are asking you the correct statement here. Okay. So now you have to predict which is paramagnetic, tetrahedral, exhibit linkage isomerism, is the inner orbital complex. Okay. Inner orbital complex means it should be D2sp3, right? Paramagnetic means no earth, it should have unpaired electron. So one thing to remember that cobalt, whenever you have NH3 in cobalt, it will be paramagnetic in nature because it will not cause any pairing here. So we can say that this A is the correct statement. As you can see here, this is CONH3. This is one of the exceptions only. So what will happen here? This cobalt is basically 27. This is the atomic number, that is 4s2 3d7, right? Now, if you lose 2 electrons here, so that will become 3d7 only. Now, we are saying that it is going to cause the pairing because NH3 is very strong field ligand. So that is why when it causes the pairing, what will happen? You have 7 electrons here, 1, 2, 3, 4, 5, 6 and 7th electron here, right? That means you are left with these many spaces here. But this, it will not be able to use this space. So this will remain empty here. This will remain empty and it will use sp3d2. Now you can see even after pairing you have unpaired electron here. Unpaired electron, that is why it is going to be paramagnetic in nature. That is why first statement is the correct statement here. Rest is MnBr2 is tetrahedral. This exhibits linkage isomerism, not possible. Is inner orbital complex, that is D2sp3, inner orbital complex. So if you want to solve this, you can, right? Nickel again is in +2 oxidation state, right? That means this will be nickel 2 positive is 3d8, right? So when it is filling the electrons 1, 2, 3, 4, 5, 6, 7, 8, it's not possible for it to be inner octahedral because if you have 5 boxes here, one box will be empty. We need 2 boxes to be empty for having D2sp3. We have just one d orbital which is empty, so that is again not possible. So answer is going to be A is the correct answer. Okay. Next is among the elements from the atomic number 1 to 36, the number of elements which have unpaired electron in their subshell. So this is very interesting. 1 to 36 you have to write down the unpaired electron. First will be your group number 1. Okay. So basically it should have NS1 here. So first will be group number 1, that is hydrogen, lithium, sodium, potassium. Right. This is group number 1. Right. Till 36 only they are saying. Na? So only till potassium we will calculate. Right. Chromium and copper, we know that why? Because they have exceptional electronic configuration where you have 4s1 and 4s1, rest of it does not have 4s1, rest of it does not have ns1 electron. That is only there in these many cases. So it is 1, 2, 3, 4, 5, 6. So answer is going to be 6 elements from 1 to 36 are there, which has NS1. It's also very, you can say, doable question that can be there in your exam, right? Now the correct statement, the earlier member of Lanthanoid series resemble calcium in their chemical property. I think the first statement is only correct, right? The earlier member of Lanthanoid series resemble calcium in their chemical properties. That is definitely the correct statement. Rest is extent of actinoid is almost similar. No, actinoid is more than lanthanoid. In general, lanthanoid and actinoid do not show variable. That is also incorrect. They show variable oxidation state. Cr4 positive in aqueous solution is not known. Definitely not. It is a stable electronic configuration. So Ce4 positive is definitely known to us, right? Okay. Next is the rate of reaction is found to be double when the concentration of one reactant quadruples, right? We are saying the rate of reaction is found to be double. Here I have given you a simple trick here, okay? A simple trick you have to solve this question, that is R dash is equals to dash of R. So the rate of reaction is found to double when concentration. Rate of reaction will get double, right? And we know the general thing is x raised to power n into R. Okay, this is the general formula. Now what is x? X is given to be, x means how much concentration is being increased here. So concentration of one reactant is quadrupled. That means 4 times. So you can say x is 4 times. It will be 4 raised to power xr. This is r dash. Now you have to compare these two values. You have to compare these two values. That means 4 raised to power n should be equals to 2. Okay. 4 raised to power n should be equals to 2. The rate of reaction is found to double when the concentration of one reactant quadrupled. The order of the reaction with respect to order should be half order. Okay, it should be a half order reaction. 1/2. Okay, because what is happening here, n will be equals to 1 by 2. Because you know what is happening here. If your n is 1 by 2, only then 4 raised to power 1 by 2. That is under root of 4 will be equals to 2. Right? This value should be equals to this value. This is what given in the question. So according to the statement that they have given me, the answer should be 1/2. That is B is the correct answer. Okay. Next is a solid that takes up a gas or vapor or solute is called. A solid that takes up gas. Let us see how many of you are able to answer. Yes. How many of you? Shweta, Harini. Let's see how many of you are actually studying. Working out for the answer now. Don't you dare tag my name in the comment once again. Gundu Mali. After your first reply, I didn't reply anything back to you, irrespective of you are the one who told me to listen that class and shut me. You don't have any rights to tell that. No. Oh God. What has happened, guys? What are you doing with your life? Huh? Someone is focusing, so you also focus, right? So Shweta, very good. Try to answer the questions. Okay. So now answer is going to be the solid takes up gas, vapor or solute, right? That is going to be absorbent. Okay. That is going to be absorbent. So in surface chemistry, just go through the simple definitions and let me just write it correctly here. This is theta, this is theta, this is theta, this is theta, and this is Ka, Pa, N1 minus theta. This is Ka n 1 minus theta. This is Ka divided by n theta. This is Ka n and theta. So this is the rate of absorption on Legmier theory, right? That is there in surface tension. Okay, that is going to be first is the correct answer. Ka, Pa, n 1 minus theta, that is the A is going to be the correct equation. Rate of adsorption is going to be R is equals to Ka, Pa, n 1 minus theta according to Legmier theory. Right? Okay. Now let us do questions of organic chemistry, I feel. Yes. Now we have questions of organic chemistry. Let us start the questions of organic chemistry now. First question is, the major product of the following reaction is. First thing what you are doing, Br2H mu is nothing but it is allylic or benzylic. Allylic or benzylic substitution of hydrogen. Right? Then KOH diluted, what it is going to do? Let us see that. Right? So basically it is a base that is going to abstract proton from the alpha position. Let us see how. So first thing is, you have Br2, which is going to attack on the alpha hydrogen. This is the benzylic hydrogen. This is the benzylic hydrogen. It is going to eliminate this hydrogen, and here you will have Br over here, and that will be replaced by Br. Okay. After that, you are adding base. Base is going to abstract proton from the acidic position. So which is the acidic position here? Now you can see, this will be H, right? Yeah, now you can see this is the acidic hydrogen. So base is going to attack on this hydrogen, and this will be converted into NH. This will be converted to NH negative here, right? After this NH negative, once, what is the work of a base? To abstract the proton, right? So it is going to abstract the proton, right? And this will be NH negative. Now, if you see this very carefully, this is NH negative. This is partially negative. This is partially positive, right? Because of this electronegativity, it will develop a partial positive charge, and hence this is going to attach here a ring formation. This carbonyl, the nitrogen attached to it, will form a ring with this carbon here, which is attached to one methyl and one Br, which is attached to one methyl here, right? Br will be eliminated here. Why? Because this N has only attacked here, and Br will be eliminated in this position, and answer is going to be C is the correct answer. Okay. Next is, you have, this is a compound, they are saying which is a suitable reagent. Okay, few reagents are given to you. So simple is, see, if you add hydroboration oxidation, then PCC, which is a mild oxidizing agent. Hydroboration oxidation means it is going to give anti-Markovnikov rule, means negative part will be attached to more number of hydrogens. Okay, so this is more number of hydrogens. Here you will have OH, and here you will have the attack of hydrogen. So this will be converted to, this is the ring, this is CH2OH. Now this is a primary alcohol. So that is why on mild oxidation, primary alcohol will be converted to CHO. So directly we can see first is the correct answer. Firstly by hydroboration oxidation, then by adding mild oxidizing agent, we can easily convert it. So answer will be A is the correct answer, right? Next is, here you have some A compound they are saying, in which you add Mg, then you add methyl benzoate, then you hydrolyze it, and you will have the formation of this thing here, right? First thing is, I'll only pick that thing which has benzene, and here I should, because of Mg here, I got a hint that there will be formation of Grignard reagent. So it should be either alkyl or aryl halide. Because of this Mg, I got a hint that it should be alkyl or aryl halide, right? What is methyl benzoate? Now with methyl benzoate, if I talk about, in this case you need 3 benzene ring. In methyl benzoate, you don't have 3 benzene ring. So that means definitely you need something which is going to give you benzene ring here. So bromobenzene, I can choose benzyl benzene. This also we can say. Acetophenol, phenol so we can't say. Acetophenol also we can't say because you need halide here, right? So one is bromobenzene, that is this benzene. Okay, this benzene. Now better understand one thing here. We are about to make a Grignard reagent. We have to break this bond, and this will be converted to MgBr, which is very, very difficult if you talk about this thing, right? Okay, so let's take this thing only firstly, right? And then methyl benzoate, right? So this is Mg, that will be converted to Grignard reagent. Then you have methyl benzoate, that is one methyl and one pH here, right? Okay. So after this, what will happen? The attack of this positive and this negative will attack on this C double bond O. This is O, this is CH3. It is going to attack on this position. One phenyl will be attached here, right? You will have the formation of C. This is O, this is H, this is pH, this is the OCH3, and this is again pH, right? So here answer should be okay, OH, na? So I think so. Here it should be okay. So here it should be OCH3, right? Okay. Here it should be OCH3, right? So here it should be OCH3, which we are going to get here, right? Okay, understood? Next is in the given reaction sequence, the major product C's. They are asking you the major product C here. So first is you have some compound here, right? So in this, they have given you the compound C8H10. They are saying that this is always in the benzene. So that means out of this C8H10, you should have benzene here, that is C6H5, right? So that means C2H5 should be there, right? C2H5 should be there. So that means to this benzene, you should have the addition of this C2H5. In that, you are doing nitration, right? So this is nitration, then you are doing bromination, then you are doing alcoholic curing. So basically what we will do here, firstly, we will just attach C2H5 here because we are left with C2H5, that is the ethyl only here. So firstly, we are going to attach on benzene C2H5. Then we are going to proceed it this way. Nitration will be there on the ortho or the para position, para being the major product that will be formed. After that, this will be bromination in presence of heat. In presence of heat or very UV light or H mu, we will do benzylic substitution. So here, in this benzylic carbon, hydrogen will be replaced by bromine. After that, you are going to add alcoholic OH, that is dehydrohalogenation reaction. So Br will be eliminated, H will be eliminated. So you will have CH double bond CH2. And hence your answer will be B is the correct answer. Is it clear? Okay. Next we have is a polysaccharide X on boiling with dilute H2SO4 at 393 Kelvin under 2-3 atmospheric pressure yields Y. Y on treatment with bromine water gives gluconic acid. Right. X contains beta glycosidic linkages only. Okay. So guys, see this. You have starch, cellulose, amylose, amylopectin. Right? All of these are made up of glucose. But if we are saying that X contains beta glycosidic linkages, so that is only there in case of cellulose, which has beta glycosidic linkages. Right? So that is my answer is going to be B is the correct answer. That is cellulose is the correct answer. Among the following, the strongest base. Now see, basicity depend upon the availability of electrons. So if you see this here you have this benzene ring in which you have NH2, electrons are available. Here you have this benzene ring in which you have NH2. At para you have NO2. Here you have benzene ring in which you have NH2 directly. At meta you have NO2. And then you have a benzene ring in which not directly NH2 is attached. Now here also electrons are being donated. Here also electrons are being donated. Here also we are donating the electron. Moreover, you have electron withdrawing group. Here also you have electron withdrawing group. Here the electrons are not in resonance. That is why they are available, right? And once they are available, that means this is going to be maximum availability of electron. That is why it is going to have the maximum basicity here, right? Next is, which structure of protein remains intact after coagulation of egg? right? After coagulation of egg, which structure will remain intact? Primary, secondary, tertiary, or quaternary? So that is primary structure. It's a very, very important question of biomolecules, that primary structure will remain intact here. Compound A, then you have this question. Compound E is formed from the following reaction, which reacts with B, give product C. Okay. So say compound A, when it reacts with Na, this is going to form CH3C triple bond CNA. Right. So this is the compound. That means either this is not the answer, this cannot be the answer, this also cannot be the answer. So answer will be A only. But still, once you have this is going to react with some compound B and going to give you this thing. So what extra attachment you have here is C triple bond C. This is the extra attachment you have. CH3, CH2, CH2, Br. So basically, this is RONA, right? If you see this, okay. This is CNA, hai na? So this is going to be CH2, this is Br, this is CH2, this is CH3. NaBr will be eliminated and you will have the formation of CH3, C triple bond C, CH2, CH2, CH3, that is formed here. So answer is A is the correct answer. Okay. Even if you know only this one, even then you will be able to answer this, right? Okay. Next is product. Now, anyone in the comment section, what is the answer for this one? Very good. Primary structure, very good. What is going on in the chat box, huh? What is going on, beta? What you guys are doing with your life, huh? Product A and B are formed. Now they are asking you which of the following set of reactions, okay? So you have double bond here. We know that this is also adding H positive, OH negative. This is also the same. Here you can say first you will form carbocation, a stable carbocation, rearrangement, and then see stable carbocation will be this one. So you'll have a carbocation, that is this carbocation will be your stable carbocation, right? And after this, there will be no ring expansion or contraction here because this is a stable ring, right? So OH negative, OH will be attached here, and hence you will have the formation of this is CH3, this is OH, right? That is going to be A. So that is going to be CH3OH, that is going to be A. So answer will be B. That is clear to us. See, even if you know only one reaction, you will be able to answer, right? So here you have anti-Markovnikov addition. That means OH is attached to that thing, that carbon which is having less number of carbons, okay? So it has, more number of carbons. So more number of carbon means OH will be attached here. That means answer will be, this is the CH3 and here you will have OH. So answer will be B is also this. So answer will be B is the correct answer, okay? Understood? Next is an organic compound when treated with concentrated HI undergoes cleavage to yield compound B and C. Okay. B gives yellow precipitates with AgNO3, whereas C tautomerizes to D. D is positive iodoform test. Okay. So you have some compound that is C9H10O, right? We have no idea what this compound is, but this compound definitely has a benzene ring because in the option you have benzene ring. And I can see there is O. That means somewhere in this compound you have O something, right? So what you have, C9H10O minus C6H5. Here answer will be C3. This is O. H, how many H? H is 5. So that means in the side chain you will have C3H5, C3H5 and O. This is the side chain. That is clear to us. Even now we are not sure. When treated with concentrated HI, undergoes cleavage to yield compound B and C. Right. So let us see all these compounds here. If this undergoes cleavage, this will be H, this will be I. Okay, here it will be H, this will be I. Okay, here this, in this case also we can specify that this will be H and this will be I. See, I is definitely double bond directly you have, I you cannot attach directly, so I feel is this has the probability that this can be your correct answer, but still you have to see other hints also. B gives yellow precipitates. Okay, you have compound B and this, so B will give you yellow precipitates. Yellow precipitates with AgNO3. That means AgNO3, it should give you yellow precipitate, means Agi precipitate is formed there, right? So that means I negative will be there. Okay. Whereas C tautomerizes to D. C is something which is having basically your enol. That means C should be enol. Now I got a hint that C should be enol. That is why it is getting tautomerized to D, that is ketone form. And that ketone is something like this. That means now I think this might not be the answer. This can be the answer because only here I am getting enol, right? Only this will when I add HI here. So H will be here, H will be over here, and I will be here, right? So it will be a benzene ring, right? Which is CH2I plus it is going to give you, this is CH2 double bond CH single bond OH, which is definitely enol. This is going to tautomerize into CH3 C double bond O and H. That is definitely going to show positive iodoform test because it is having this kind of group. Right? That means C is the correct answer. Okay, that means C is the correct answer. Got it? Yes, everybody very disappointed by your chats. Very disappointed. If you think that I am not able to see anything, I am exactly able to see everything that you guys are doing here. Right? Okay? Got it? I think we should stop conducting these sessions for you. That is a wastage of our energy and our time also. Right? So I think definitely that is not a good thing that you guys are doing here. Not for me, for yourself. I don't know what are your future plans. You want to be a gunda or what you want to be, I have no idea. Right? Which one of the following compounds is inactive towards SN1 reaction? Towards SN1 reaction, which of the following compounds is inactive? SN1 reaction means it should have a carbocation. So the one which has unstable carbocation will be inactive towards towards SN1 reaction. Okay, so here definitely you have a 3-degree carbocation that is stable. Here you have a allylic carbocation which is obviously stable. Here you will have a carbocation which is going to have a bridgehead carbocation, which is definitely not stable at all. On bridgehead, you need sp3 hybridization. Here you will have sp2 hybridization if it is a carbocation, and definitely sp2 hybridization is not stable on the bridgehead position. So answer will be C is the correct answer. Then there is an aromatic compound on reacting with very important question, on reacting with NaNO2HCl at 0 degree forms benzyl alcohol and nitrogen gas. Okay. The number of isomers possible for the compound is, see, first you have to see which compound. They are saying a compound from C7H9N subtract C6H5, you will have subtract C6H5 here. What you will have here is C67894N. Okay, this is what you will have. So I think it can be because CH4N can only be adjusted like this. है ना? Now, if they are saying that this is the compound C4, CH4N, on reacting with NaNO2, it will give rise to which thing? It will give rise to something like this. That is, it will cause diazotization, right? At 0 degree to form benzyl alcohol. Definitely, why? Because this diazotization, this is connected to a carbon which is in the alkylic form. So that is why this is not at all stable. So this will directly get converted to OH, right? And now here you will have the release of nitrogen gas. The number of possible isomers for the compound A. Now they are asking you the possible isomers for this compound A. Let us see the possible isomers here. First thing was to identify that compound. Now the possible isomers may be this NH2 can be an aniline and CH3 can be the substituent here. One substituent on ortho, then para position, then meta position. Ortho, para and meta. Then also you can have NHCH3. That can also be the possibility, NHCH3. So all of these are the isomers. That is, it is having 5 isomers here. Okay. Next is iodoform reaction is answered by all except for which? It is answered by all except for which? Iodoform reaction. See, iodoform is answered by this thing, or you should have this kind of alcohol, right? So if you see this here, ethanol shows, this will not show because this is not CH3, CHOH, so this will not show. What is this? See, I'm not able to identify which compound is this. What is this compound? CH3C, CH3OH. I think there is some typing mistake here. There is some typing mistake because that is, I'm not able to understand what compound exactly is that, right? So answer will be that this CH3CH2, that will not show anything. Iodoform reaction is answered by all compounds which is having CH3C double bond O compound, right? So hence answer is going to be D is the one which is not going to show iodoform test here, right? Because it does not have CH3CO or CH3COH group, right? That is why it is not going to show. Match the reactant. Now, I think this is the last question of today. Let us see that. Last or maybe the second last. Okay. First is acetic acid, stiffen, Friedel-Crafts, HBZ and Coles. What is the reagent here? So acetic acid is there, the reactant is there in HBZ, Hallbohar-Zielinski reaction. For alpha mono substitution, right? Then sodium phenate is there in Coles reaction, right? Okay. Then you have methyl cyanide is there in Stephen's reaction, C triple bond N. Toluene is there in Friedel-Crafts reaction. Okay, you can use toluene there in Friedel-Crafts reaction. So answer will be yes. Okay, toluene can be formed in Friedel-Crafts reaction. So answer will be your answer is going to be D is the correct answer. According to you can match this. DNA multiplication is DNA multiplication. Anybody? Last question here. Let us see. Okay, let us see. Let us see how many of you are able to answer this. DNA multiplication is called translation, transduction, transcription, replication. Which one of the following? So DNA multiplication is nothing but it is transcription. Okay, so answer will be B. C is the correct answer. Okay, understood? Yes, everybody. But today it was not fun doing this class. I saw you guys chit-chatting with each other only. So that's why I ignored your chats, right? Reason being, what a teacher will feel seeing the chats that you are doing this and that, you are fighting with each other. I don't know. It feels very sad to see you guys fighting over unnecessary things that are not even important in your life, right? So I don't know why you guys are doing all these things here, right? Okay. DNA multiplication is that is replication. Yes. DNA multiplication is yes. Okay. Now it was very sad to see you all fighting with each other. That was actually very, very sad. Now, students, for all the students who are actually very serious about this exam, right? So then, students, we have this test series for you, that is SRMJEE test series. You can see SRMJEE test series that is only available for you at 649 rupees. Okay, and if you're preparing for other exams also, VAT EEE, that is also available for 649. KCT, Comet K, all the test series are available for 649 rupees. And if you're looking for a test series which will provide you everything, then that is available at 1299. Okay, so that means you will be benefited with which thing, right? Definitely, if you are preparing for at least more than 2 exams, then go for extra mile engineering test series that is available to you, right? In this test series, you have all the different exams like MHT, KCT, VAT EEE, ISR, SRM, KIIT, WB, BITSAT, Comet K, all the exam test series will be available to you in this particular test series, right? So what you need to do and how many tests you will get here in each test series. Let's say for SRM you get 10 mock tests. For VAT EEE you will get 10. If you purchase one, you will get 10. If you purchase extra mile engineering, for each exam you will get 10. That means total you will get 100 mock tests. 10 test series for each exam and 10 exams will be there in the full test series. So that is 10 multiplied by 10 is 100 mock tests you will get in that, right? So according to you, you can choose that, right? Yes, better, definitely we are going to take JEE advanced session, but what I see is the crowd yesterday was really good, right? I enjoyed teaching you guys, but today the crowd was not so good. So I would advise all of you to be little more active and share this with your friends, and so that I can also feel motivated, right? And I can also feel excited to teach you. Otherwise, so the when you are chit chatting with each other, fighting with each other, the teacher loses the motivation to teach you, right? Because when I see non-seriousness in you, how can I be serious then, right? Then I feel like why I'm doing all this for, like, for whom? Like for you guys who are happy in wasting their time while studying, right? So don't do that, right? So be very focused in your study. That is definitely going to help you in long run. All these fighting and swag you are showing to each other, that is not at all worth it, right? You're going to laugh at yourself for doing all these things. Trust me on that, right? Okay. Okay then, students, bye bye, take care. This is Diksha Kaushal signing off, and I want to see in the comment section who is going to be there in tomorrow's lecture, that is for KCT, and the lecture will be at 12 p.m. sharp. Till then, bye bye, take care, see you all.